Hi guys, welcome back to my channel. Today let's do a solubility problem. Alright, so the question reads, which compound is most soluble given the following KSP? A, B, C, D, right? These are all the KSP. Okay, you're welcome to pause the video and give it a try. Otherwise, we're going to dive into this. So KSP is the equilibrium constant for an ionic solid dissociating into ions in water, right? So if we have the same amount of moles that are dissociated, then we know that the higher the KSP, the more soluble, right? More ions are dissociated, right? Okay, but this is not the case for our question, right? Because as you can see, all these stuff that they dissociate into different modes of ions, right? So you can't not just say, okay, which number is the biggest, and then I pick which one is more soluble, right? That's not the case. So to really solve this, the traditional, we're first going to talk about the slow way out. We're going to talk about how we would have solved it for our GenChem class, let's say, right? And then after we go through the complicated traditional computing way, and then I'll tell you a trick. I'll teach you a trick that you can quickly solve it in about 5 seconds on MCAT. All right? Okay, so let's dive into this. So let's first analyze answer choice A. How does that dissociate? Okay, so answer choice A is FeCl, right? So when you put this in the water, then it dissociates into 1 mole of iron and 1 mole of chlorine, right? Okay, so I have this plus and negative here, okay? Whereas B, you see FeCl2, it would dissociate into Fe and 2 moles of Cl minus, right? So that you see this A and B, they already have different amounts, different number of moles of their products, right? Okay, so that you can't really just say, okay, I'll just pick whichever KSP is the largest to pick up the most soluble one. That doesn't work here. We have to calculate their molar solubility, right? Molar solubility. Okay, all right. So now let's do the GenChem, the traditional, the complicated way, okay? How we do the molar solubility. We're going to use the ICE table, right? So ICE, okay? I is the initial, C is the change, and E is the equilibrium, right? So that we say originally I have X moles of FeCl and zero moles of the products, right? The reaction hasn't happened yet. And then the change is when the reactions are happening, I use up this FeCl, my reactant. So I minus X, and then I add 1 mole, and then for each product, right? So when I'm at the equilibrium, I have 0, right? X minus X, 0. And then this is X and X, right? So that's how you do it. And then the KSP really equals what? Really equals Fe plus times Cl minus, right? Just like the equilibrium, and then the Ka, Kb, all these things, right? That's how we write it out, okay? That's KSP. And then you will say, okay, so my Fe was what? My Fe is X, okay? So X, I plug in. And then what is my Cl minus? That's another X, okay? So KSP is what? So it's answer choice A, 1 times 10 to the negative 3, okay? So it's 10 to the negative 3 equals X times X, right? So the X squared equals 10 to the negative 3, and X equals the square root of 10 of negative 3, okay? So that's how you solve the solubility, this X, okay? So this X will really just give you the molar solubility, and then you get the molar solubility for each one of these, and then you pick the largest number to say, okay, this choice is the most soluble one, right? Okay, I know it's like it's insane, right? You're not going to do this on MCAT, but I'm just showing you the traditional way before we can fully comprehend the trick that I'm going to teach you, okay? All right, so now let's do B, okay? Let's do B. So B is dissociating into two moles of Cl, right? Okay, so the difference is if I were to draw ICE, my ICE table, of X moles of my reactant, I have 0, 0 from the get-go, and then I minus X as I change, the reaction happens, and then I have a plus X and plus 2X, right? 2 moles of this reactant. Okay, so the E equilibrium is really 0, X, and then 2X, right? So my KSP in this case is Fe 2 plus. Okay, and then Cl minus squared, right? Because I have this 2 here, okay? All right, so in this case, what is my KSP? Oh, it's also 10 to the negative 3, okay? Times, okay, what is Fe? Fe is x. What is Cl? Minus Cl minus a 2x, right? So I have a 2x squared, okay? So in this case, I get 4x cubed, right? Equals 10 to the minus 3, and then calculate x, which is impossible on MCAT, okay? But that is how we do in GenChem, right? That's how we learned in our GenChem class, okay? All right, so I already have this answer choice C for you, okay? It's just the same thing. We can go through this, right? So this time for the answer choice C, it's FeCl3. So FeCl3 would dissociate into 1 mole of Fe3 plus and 3 moles of Cl minus, right? So I have a 3x here, 3x here. So if I were to plug in my solute KSP, which is 1 times 10 to the negative 12 equals Fe3 plus times Cl to the power of 3, okay? Okay, so that gives me this math to do, okay? So is it impossible to solve this like under a minute on MCAT, right? It's not possible, okay? So let me just teach you a trick, okay? Let me just teach you a trick. So as you can see, so D is really the same, okay? We don't have to write it out. We just need to know like how many moles products do you have, okay? All right, so in this case, we see that we have this x squared, right? X squared equals my KSP, okay? So that I know, okay, so it's x squared equals 10 to the negative 3, right? Okay, don't calculate x yet, okay? Do you think that's correct? Right, that's correct, okay? So in the case of answer choice B, okay, since we raised the power we raised to the second power, really this expansion comparing to this exponential growth, this 2 is just nothing. So I want you to ignore this 2. Just cross it out on MCAT, okay? You will be fine, okay? You don't cross it out on your GenChem test, but cross it out on MCAT. This 2, you cross it out because it's really just nothing compared to this exponential growth, okay? All right, so after you cross out the 2, what you get? You get x times x to the square equals 10 to the negative 3, right? So you have a x cubed times 10 to the negative 3, okay? All right, don't solve x yet, okay? X equals what? I don't know. I don't need to know, okay? Don't solve that yet, okay? So this is the case for answer choice B, okay? And then for answer choice C, please cross out this 3, okay? Because I raised to the power of 3, then comparing to this exponential increasement, this 3, you can really just ignore that, okay? It's negligible, okay? So if I cross it out, I have what? I have a x times x to the third equals my KSP is a 10 to the negative 12, okay? So my x to the 4th equals 10 to the negative 12, okay? So for answer choice D, it's the same deal, right? You have it doesn't matter, it looks complicated. You have 4 moles of stuff, right? That gets disassociated. So you x to the 4th equals 10 to the negative 3. That's the case for D, okay? So, okay, now let's write it out again, okay? So A, B, C, and D, right? And then X is my molar solubility. It's a number that I can use to decide which one is the most soluble, right? So, okay, so for A, my x squared equals what? 10 to the negative 3. For B, my x cubed equals 10 to the negative 3. For C is x to the 4th equals 10 to the negative 12, all right? And then what about for the D? For D is also x to the 4th equals 10 to the negative 3, okay? So how are you gonna solve X? Don't be silly or do the square root, in the struggle and the sweat and you want to pull your hairs out. Don't do that, okay? So you just basically raise it to 1/2 in this case, right? Because when you raise this to 1/2, you get x, right? So here, x is 10 to the what? Negative 1.5, right? So in this case, okay, let's raise it to the 1/3. So you get x, right? So you raise it to the 1/3, and then x equals negative 1, right? And then in this case, how do we do that? X equals, we raise it to the 1/4, right? And then this is a 1/4. So you have a 10 to the negative, I'm sorry, here's 10, or 10 to the negative 1 here. And then this is 10 to the negative 3, okay? All right, the last one is x equals 10 to the negative 0.75, okay? All right, so now you can compare, right? Now it's clear that they are all 10 to the whatever, right? Okay, so which number is the biggest, right? This one. This is the biggest number. I mean, 0.05 is the smallest number, but negative 0.75 is the biggest number. So 10 raised to the biggest number gives you the biggest x, right? So this is number one. And then which one is number two? Number two is this one, right? Number three is this one. And number four is this one. So number four is the least soluble, right? And then number one is the most soluble, right? So answer choice D is my answer, right? This is the most soluble. I would pick this. So on MCAT, how would you do it? So when you see this, you don't even need to write out the ice table. Definitely don't do that, right? So you would see, okay, so this is 2 moles, okay? So I raise it to 1 half. Oh, there, 3 moles, okay? And then there's a 4, 1 to the 4, and then there's a 4, okay? 4 moles, right? Both reactants, you add the number of moles together, okay? I mean, both products. Okay, so in this case, you can also just quickly do the, okay, 10, okay, it takes you 1 second to raise it to the 1 half, and then you get a 10 to the negative 1.5. This you get a 10 to the negative 1, 10 to the negative 3, and then 10 to the negative 0.75, and then you say, oh, voila, this is the biggest number. So this is the most soluble that the question is asking for, and this is my answer, right? Literally like a 1, 2, 3, 4 seconds for you to calculate their molar solubility in this fashion, right? You raise each KSP to the what? To the 1 over how many moles of products, right? You raise it to 1 over how many moles of products power, and then you get to decide, okay, which one is the biggest number, and then pay attention to negative here, right? And then you will pick which one is most soluble. I think it would take, 7 to 8 seconds to be fair. All right, I hope that's helpful.